Hi students, good evening everyone. So let us continue with the morning concept first. So in the morning class we were discussing about the test for amines. We have seen the first test, carbylamine test, which is given by only primary amines, both aliphatic and aromatic. Then next one is by using Hinsberg reagent. So Hinsberg reagent is benzene sulfonyl fluoride. So primary amines will react with Hinsberg reagent and the product form will be soluble in alkali. Secondary amines will react with Hinsberg reagent, but they don't have any solubility in alkali. Then third one is tertiary amines does not react with Hinsberg reagent. That is Hinsberg reagent to distinguish primary, secondary and tertiary amines. Next one is with nitrous acid. So with nitrous acid, primary amines, aliphatic primary amines will give alcohols and along with the liberation of nitrogen gas. So this is the only class of amines which will be liberating nitrogen gas with nitrous acid. So that is the test for aliphatic primary amines. If you take aromatic primary amines, they react with nitrous acid, giving benzene diazonium salts as the products. And the temperature must always be between 0 and 5 degrees centigrade. If the temperature increases by more than that, again benzene diazonium salts will be giving phenols as the product. That is how primary amines react. Secondary amines, both aliphatic and aromatic, will be giving N-nitrosoamines. Will be giving N-nitrosoamines as the products. They are yellow oily compounds. So N-nitrosoamines on acidification we will be getting a green colored solution. Further basification we will be getting a deep blue colored solution. Further dilution we will be getting a red colored solution. That process is called as Lieberman-nitroso process or Lieberman-nitroso reaction. So for secondary amines identification, we have Lieberman-nitroso reaction. Then for tertiary amines, third one is tertiary amines. Tertiary amines. First, let us take aliphatic tertiary amines. Let us take aliphatic tertiary amines. Aliphatic tertiary amines. So aliphatic tertiary amines, for example, if I take R3N, is a tertiary amine, aliphatic. So this on reaction with nitrous acid. This on reaction with nitrous acid, or let me write as HN4. So this lone pair will be attacking this hydrogen, which is present as H plus, and we will be getting salts. R3NH plus, NO2 minus. R3NH plus, NO2 minus, right? So nitrite solvent, this is called as trialkyl ammonium nitrite. Trialkyl ammonium nitrate, which is a salt. So aliphatic tertiary amines will be giving nitrite salts. Aliphatic tertiary amines will be giving nitrite and salts. If I take aromatic tertiary amines, for example, aromatic tertiary amines. Aromatic tertiary amines will give electrophilic substitution product. It will be a type of electrophilic substitution reaction. It is a type of electrophilic substitution reaction. So if you take an tertiary amine, this on reaction with nitrous acid. I am writing it as this one. So at the para position there will be hydrogen. Hydrogen from here, OH from here will be removed as H2O. NO will be substituting here. So we will get a substitution product. We'll get a substitution product. So tertiary amines will be undergoing electrophilic substitution reaction. The name of this is para-nitroso N-N dimethyl aniline. So without this, we know that it is N-N dimethyl aniline. At the para position, there is nitroso group, para-nitroso. para-nitroso N, N dimethyl aniline. So this is how nitrous acid reacts with tertiary amines. With aliphatic tertiary amines, we get nitrite salt. With aromatic tertiary amines, we will be getting an electrophilic substitution product. So NO group will be substituted at para position. Okay. So this is how primary and secondary and tertiary amines can be differentiated by using nitrous acid. Okay, na? Then there is a last test which is called as azodite test. Last test. Fourth one, no? One is carbylamine. Next one is Hinsberg. Next nitrous acid. Fourth one is azodite test. Azodite test. So this test is given by only aromatic primary amines. Only aromatic primary amines. Only for aromatic primary amines it is. So what happens is, if we take an aromatic primary amine, for example, if I take aniline. So this is made to react with HNO2 plus HCl first. What product you will get, students, in this step? What product will you get in this step? Benzene diazonium chloride, no? Benzene diazonium chloride. What is the name of this reaction called? Diazotization. The name of this reaction is called as diazotization. So you get benzene diazonium chloride. You will get benzene diazonium chloride. This is the product. Benzene diazonium chloride. So this benzene diazonium chloride is made to react with beta naphthol. So benzene diazonium chloride is made to react with beta naphthol, students. What is this beta naphthol is? So two benzene rings are present here, right? So on one of the benzene ring, it will be OH. This is called as beta naphthalene. Without this, this is naphthalene, right? Naphthalene. So if there is a OH group, it is called as beta naphthol or 2-naphthol. It is called as beta naphthol or 2-naphthol. Beta naphthol is the common name. IUPAC name is 2-naphthol. Anyway. So what you will get is, you will be getting an orange red colored dye. Orange red colored dye. So how that orange red colored dye will be formed here is, there is an hydrogen present here. So hydrogen from here and Cl minus from here will be removed as HCl. And you can see this triple bond gets converted into double bond and it will be in conjugation with this benzene ring in this way. Triple bond gets converted to double bond. This will be the product formed. So this is an orange red colored dye. Orange red colored dye. So if you are getting an orange red colored dye by doing these steps, then that is called as azo dye test. It will be given only by aromatic primary amines. So what is azo dye test is? First taking aromatic primary amine, doing diazotization, we got benzene diazonium chloride. Benzene diazonium chloride is made to react with beta naphthol. Beta naphthol. So on reacting with beta naphthol, if you are getting an orange red colored dye, it confirms there is an aromatic primary amine. Okay, na? So only for aromatic primary amines this test is done. Right? So this test is important, students, for entrances. Important for entrance exams. Right? No need to remember the reactions. Just remember that which amines will be giving what test. So aromatic primary amines will be giving azo dye test. Confirmation is orange red color dye will be formed. Completed. So these are the different tests for amines. These are the different tests for amines. Then there are another group of nitrogen compounds given in your NCERT textbook, that is diazonium salts. Okay, but it is removed for theory exam, only for entrances. So next one is diazonium salts. So in the diazonium salts, so one salt which we are going to discuss is benzene diazonium chloride. One salt we are going to discuss is benzene diazonium chloride. Benzene diazonium chloride. So coming to the preparation of benzene diazonium chloride. So already we have seen how this is prepared. So it is prepared by a reaction called as diazotization. It is prepared by a reaction called as diazotization reaction. Only one method of preparation. So diazotization reaction will be given only by aromatic primary amines. It is given only by aromatic primary amine. So this is an aromatic primary amine, aniline. So this on treatment with HNO2 plus HCl. So temperature conditions are always important. It must be ice cold temperature conditions. 0 to 5 degrees centigrade. Ice cold conditions. So the product you will get is benzene diazonium chloride. Benzene diazonium chloride plus H2. So this is how the preparation is done. Okay. So already we studied diazotization reaction. Right on this we will see the properties. See, to show it in lab, no, we need the reagents, right? So that they need to provide. First, we need to get a secondary amine, right? That will not be available in our college laboratory. So that's why we can't do. Okay. And college won't allow us to bring any chemicals from outside into the laboratory. If they allow, I would have done that in the lab, but they won't give permission. That is the rule. Chemicals will get outside. By paying some amount, I can get the chemical, but college won't give the permission. Completed? Next, coming to chemical properties of diazonium chlorides. Chemical properties of diazonium chlorides. Chemical properties of diazonium chloride. Okay, na? So in diazonium chloride, no, there are two types of properties. For example, if we take the diazonium chloride, this is the formula of diazonium chloride. There are two types of chemical properties. First type of chemical properties are where the nitrogen group will be replaced with some other group. Where the nitrogen group will be replaced by some other group. That is the first type of properties. Second type of properties are involving nitrogen, where nitrogen will be present. So one is by replacement of nitrogen, other one is by retention of nitrogen. So first we will see what are the chemical properties shown by replacement of nitrogen. Right. So the first chemical properties are, first type of chemical properties are reactions involving replacement of nitrogen. That means nitrogen will be removed from the compound. Nitrogen will be removed from the compound. For example, first one, let us see. Replacement by halide ions. Replacement by halide ions. And replacement by halide and cyanide. Replacement by halide and cyanide. That means nitrogen will be removed and halide ion. Halide ion here, either it may be chloride or it may be bromide. And cyanide is CN-. So the two can be replaced. For example, if I take C6H5, N2 plus Cl minus. So if this N2 plus has to be replaced by Cl, you will get C6H5Cl plus nitrogen gas. If it has to be replaced by bromide, you will get C6H5Br with the liberation of nitrogen gas. If it has to be replaced with cyanide, so I can take KCN in the presence of CuCN, then I will get C6H5Cl. Tell me students, what reagents you need here to get this reaction? Yes, CuCl in the presence of HCl, CuBr in the presence of HBr. What is the name of this reaction called? Yes, it is called as Sandmeyer reaction. It is called as Sandmeyer reaction. Very good, right? But in Sandmeyer reaction, no, we studied only about chlorine and bromine, but we didn't study about cyanide. So even this reaction is a Sandmeyer reaction. Even this reaction is also called as Sandmeyer reaction. Okay, na? So these two already you know, we studied in halogens. So even this now I am adding. So it is also an example of Sandmeyer reaction. Okay. CuCl in the presence of HCl, CuBr in the presence of HBr, CuCN in the presence of KCN. This is catalyst. CuCl, CuBr, CuCN is catalyst. If you take HCl, you'll get chloride ion replaced. If you take HBr, you'll get bromide ion replaced. If you take KCN, you'll get cyanide ion replaced. Then there is another reaction to get chlorobenzene and bromobenzene from benzene diazonium chloride. Just by changing this catalyst. What is that reaction, students? Yes. Instead of taking copper halide, you can take just copper. It is called as Gutterman reaction. Very good. So that also we can write here. Complete writing this one. So in the same replacement by cyanide, we have one more reaction called as Gutterman reaction. By changing the catalyst, instead of copper halide, we'll be taking copper powder. C6H5N2 plus Cl minus. But we have only two reactions here. Copper in the presence of HCl, copper in the presence of HBr heating. So what happens here? You will get C6H5Cl plus N2 plus UX. In the same way, C6H5Br plus N2 plus UX. X means chloride. CuCl here also CuCl. Okay, na? So this reaction is called as Gutterman reaction. It is called as Gutterman reaction. Okay. Next one. Replacement by iodide. Replacement by iodine. Tell me, students, what I need to do in order to get iodobenzene from benzene diazonium chloride. Yes, Ki on warm conditions. Very good. So by taking benzene diazonium chloride on reaction with Ki under warm conditions, we get C6H5I plus N2 plus KCl. We get C6H5I plus N2 plus KCl. This is replacement by iodine. Next, for replacement by fluorine, what is the name of reaction? Yes, Bal-Schiemann reaction. Very good. It is called as Bal-Schiemann reaction. That also we'll write. Write down till here. So all these reactions we studied already. Same reactions. Next is replacement by fluorine. Replacement by fluorine. So replacement by fluorine, it is called as Bal-Schiemann reaction. It is called as Bal-Schiemann reaction. So first we will be taking benzene diazonium chloride and we will react it with HbF4. If you remember, we will react it with HbF4. So it is called as tetrafluoroboric acid. Tetrafluoroboric acid. So from this, what will happen? So hydrogen from here, chlorine from here will be removed as HCl and BF4 minus will be attached here. You will get N2 plus BF4 minus. So this is called as benzene diazonium. Benzene diazonium tetrafluoroborate. Benzene diazonium tetrafluoroborate. So this if I heat, you will get fluorobenzene plus nitrogen gas plus BF. So this is how we can prepare fluorobenzene by using Boltzmann reaction. Okay, na? So all these reactions we have studied. Now one more reaction I am going to introduce here. That is replacement by NO2 group. Instead of fluorine, I want to replace it with NO2 group. So for replacing with NO2 group also, the process will be the same till here. For replacement by NO2 group also, the process will be same till here. So benzene diazonium chloride, you will react it with HbF4. You will be getting benzene diazonium tetrafluoroborate. Then the next step will be a different step. By reaction with NaNO2 in the presence of copper and heating. Because NO2 group we need to add, no? So I will be heating with copper as catalyst with NaNO2, sodium nitrite. So we know that sodium nitrite will easily give Na plus and NO2 minus 1 because it is an ionic compound. So in this case, you will be getting nitrobenzene. You will be getting nitrobenzene plus nitrogen gas plus NaBF4, sodium tetrafluoroborate, salt of this acid. Okay, na? So this is how you can introduce NO2 group. Similar to Boltzmann reaction, but after that to get fluorobenzene we will be heating. So here we will be heating in the presence of NaNO2 and copper as catalyst. Okay. Next one is replacement by OH group. Replacement by OH group. So nitrogen has to be replaced with OH. See, students, benzene diazonium chloride is, we know how benzene diazonium chloride is prepared. It is prepared by the reaction of aniline with HNO2 and HCl at a temperature of 0 to 5 degrees centigrade, ice cold conditions. We get benzene diazonium chloride. So we know the preparation. Then see here, this nitrogen has to be removed with OH and it has to be replaced with OH. So if I remove this and replace with OH, I'll get phenols, right? So how it can be done? By raising the temperature to greater than 5 degrees. So if the same reaction is done by increasing the temperature to greater than 5 degrees, then we will be getting phenol. Then we will be getting phenol. So take benzene diazonium salts, heat it to a temperature greater than 5 degrees, we will be getting phenols as the products. Already we have seen this reaction in the morning, right? Until the temperature is less than 5 degrees, benzene diazonium salts will be stable compounds. If the temperature increases further, they will be decomposing to form phenol. N2 plus HC. So all these reactions we have discussed previously on the students, except introduction of NO2 group we have seen now. Then one more reaction I'll give now. Only those two are new reactions. Remaining all the reactions we have seen in haloalkanes and haloarenes as well as in the morning classes. Okay. Then the last one is replacement by hydrogen. What product you will get, students, when you replace nitrogen with hydrogen? Benzene, no? You need to get a benzene. So you are adding hydrogen means it is nothing but reduction. For reduction, we need reducing agents. And we know that diazonium salts, nitrogen gas will be ready to leave because we know that nitrogen gas is a highly stable gas due to the presence of triple bond between the two nitrogen atoms. So by using very weak reducing agents also the reaction can be done. Right? So the reducing agents I am going to use here are, one is hypophosphorus acid, other one is alcohol. Right? So benzene diazonium chloride on reaction with hypophosphorus acid, which is a reducing agent. So this will be converted to benzene. This will be oxidized to H3PO3, phosphorus acid plus N2 plus HCl. So H3PO2 will be converted to H3PO3. It is a reducing agent, it will be oxidized. In the same way, we can do the reduction by using alcohol also. N2 plus Cl minus on reaction with C2H5OH. Ethanol. This is also a weak reducing agent because it will be ready to give hydrogen. It is acidic in nature. Now what happens? We will get benzene plus. This will be oxidized to aldehyde. We know that alcohols will be oxidized to aldehydes in the presence of weak oxidizing agent. This will be oxidized to aldehyde plus N2 plus X. Yeah. So only this reaction you are studying now, newly, right? Completed. So these are all the reactions involving replacement of nitrogen, where nitrogen is replaced with some other group. Okay, na? Then the second type of chemical reactions are involving retention of nitrogen group, where the nitrogen group will not be removed from the compound. Right? So second type of chemical reactions are reactions involving reactions involving retention of nitrogen, involving retention of nitrogen. So reactions involving retention of nitrogen. This type of reactions are called as coupling reactions. This type of reactions are called as coupling reactions. So what are these coupling reactions is? These are electrophilic substitution reactions. Electrophilic substitution reactions given by phenols and anilines. Anilines, it may be any aniline, right? Phenols and let me write as aromatic amines. Phenols and aromatic amines. It may be primary, it may be secondary, or it may be tertiary. Phenols and aromatic amines with the diazonium salts. With the diazonium salts. So these are electrophilic substitution reactions. For example, if I take benzene diazonium chloride, first if I make it to react with phenol. So we know that phenol OH group on benzene ring is an electron donating group. So we'll get both ortho product as well as para product, but the major product will always be para product, right? So at the para position there is hydrogen. So hydrogen from here and chlorine from here will be removed as HCl. Triple bond gets converted to double bond, and the product formed here will be like this. Triple bond will be converting into double bond, and you'll get a bond with this benzene ring in this way. So you can see there will be continuous conjugation. Double bond coming here, pi bond coming here, benzene. So this double bond will be in conjugation with both the rings. So that's why these compounds are highly stable compounds. And these are colored compounds called dyes. They are colored compounds called as dyes. So the name of this is para-hydroxy azobenzene. Para-hydroxy azobenzene, right? So which is an yellow colored dye. It is an yellow colored dye. Whenever there is N double bond N, no students, it is called as azo, right? Whenever there is a bond between nitrogen and nitrogen, it is called as azo. That's why they are called as diazonium salts. Okay. So para-hydroxy azobenzene. It is an yellow colored dye. Sorry, orange colored dye. With amines will get yellow color. No need to remember the colors. But this will be dyes. Orange dye it is. Completed. So one more example with amine alkyl aniline. One more example with aniline alkyl. So this is benzene diazonium chloride. On reaction with aniline. So we know that NH2 group on benzene ring is also an electron donating group. So hydrogen from here and Cl minus from here will be removed as HCl. So triple bond will be converted to double bond. So you'll get N double bond N. So which will be directly in conjugation with the other benzene ring here. So this is called as para-amino. This is called as para-amino azobenzene. para-amino azobenzene, which is an yellow colored dye. So in this way, benzene diazonium salts will be giving only two types of chemical reactions. One is involving replacement of nitrogen. Other one is involving retention of nitrogen. With retention of nitrogen, those reactions are called as coupling reactions. They are simple electrophilic substitution reactions. Okay. So these are the properties of benzene diazonium salts. Okay, na? Right. So this is about the chapter called as amines, students. Okay. So actually, if we turn the pages to back, number of reactions seems to be more in amines, but very easy reactions, because in the preparation of amines, one reaction we have seen as any nitrogen containing compound on reduction we are going to get amines. There only we have written some 8 to 9 type of compounds. So in that complete part, what is the important thing you need to keep in mind? One is for amides. For reduction of amides, we need to use only one reducing agent. What is that reducing agent, students? Lithium aluminum hydride. So that point you need to remember. For any other nitrogen compound, no, whether it may be nitro group, or whether it may be cyanide, whether it may be isocyanide, whether it may be oximes, whether it may be imines, any other nitrogen containing compound, you can use any reducing agent. But only for amide, you need to use lithium aluminum hydride. If you keep that point in mind, any reaction you can write. Okay. But between cyanides and isocyanides reduction, you need to be careful. Cyanides on reduction, what amines you will get, students? Primary amines. Isocyanides on reduction, secondary amines. This is one reaction. Then regarding isocyanides, hydrolysis. Hydrolysis of isocyanates will give you primary amines. So in the preparation, no, compare in all the compounds, these three reactions are important. Then two named reactions we have seen. One is Gabriel thallamide synthesis, other one is a Hoffman bromamide reaction. These two named reactions are important, students. You need to write and practice. Okay, so in Gabriel thallamide synthesis, what we are doing? We are taking thallamide. We know that that compound is acidic. There is an acidic hydrogen. You will react it with KOH. You will get a salt because it is an acid-base reaction. Salt is made to react with an alkyl halide. Then hydrolysis of alkyl halide will give you primary amine. Then Hoffman bromamide degradation reaction. From name itself we can get bromamide. That means bromine plus amide. Reaction is between an amide and bromine in the presence of a base. Degradation, because you will be getting one carbon atom less from the number of carbon atoms in the amide. That's why it is called as degradation. Okay, now which carbon is removed, students? Whether the carbon from alkyl group or C double bond O group in amide, which is removed. Carbon from alkyl group is removed in amide or CO is removed. CO. Carbon from CO is removed. C double bond O group will be removed as CO2. I have given you the mechanism also. And what is the stable compound formed during the mechanism, student? Isocyanate. Remember, R, N double bond, C double bond, O. Remember it for entrances. Mechanism is not required for theory, but I have specifically rounded off that compound. In Hoffman bromamide reaction, you will get isocyanate, alkyl isocyanate, or N double bond, C double bond, O. Okay, na? So those are the two important named reactions. 2 or 3 times you practice, it will be convenient. Okay, now that will be important for theory exam as well as for entrances. Then in chemical properties, today only we have discussed. Last class we have seen acylation and Alkylation. Alkylation means we need to react it with alkyl halide. Acylation means either reaction with acid halide or ester or acid anhydride. If you are reacting it with acid halide, HCl will be removed. If you are reacting it with ester, alcohol will be removed. Hydrogen from amine. The good living group from esters. From esters, the living group is OR dash and hydrogen will be removed as alcohol. From anhydrides, hydrogen from amine or COO group from anhydride will be removed as an acid. So very easy to write. Just if you observe the reactions carefully, it will be very easy to write the products. Okay, now then we have seen the test for amines. This you need to read 2 or 3 times so that you remember. No need to remember all the reactions, the products and everything. Just try to identify while the entrance reactions are there. Just try to identify which test is used for which amine, what will be the final observation. Okay, na? So this is about the chapter amines. Okay. So MCQs in the next class, regular class only we will do in morning classes, right? Then we were discussing alkynes, right now students? Still where did we discuss, you remember? I remember ozonolysis is done for alkynes. What was the last reaction, students, in chemical properties? Electrophilic addition reactions we have done. Electrophilic addition reactions. Addition of HBr, addition of H2O in the presence of mercury. Done all those. Tell me what was the last reaction we have written? Last reaction what we have written? Addition of HOX, huh? Okay. Addition of HOX. Alkanes only we were discussing last class. In Kvpy class. Oh, model question papers for board exam you want? Okay, I'll share it in the group. Okay, model question paper for board exams, I'll share it. Right. See students, in the model question paper, just observe the question numbers. First question and second question will be there from solutions. In the final exam paper also, the question will be from solutions only. Here the question number, whatever is the question from which chapter, in the same way in final exam also the same question number from same chapter you will get. Okay, na? First and second question in the model question paper, if it is from solutions, there also in the final exam theory paper, first and second question will be from solutions. Third question if it is from electrochemistry, in the final theory paper also third question will be from electrochemistry. Okay, na? I'll share it later, right? Let us discuss about chemical properties of amines. I think electrophilic addition reaction, still addition of HOX is done. We'll continue with the next chemical properties. Oxidation of alkynes. Oxidation of alkynes. Oxidation of alkynes. First one is by using cold dilute alkaline KMnO4. Cold dilute alkaline KMnO4. Cold dilute alkaline KMnO4. So in this case, if it is a terminal alkane, students, if I take HC triple bond CH, this is an oxidation. So we know that this is a terminal alkane. From this, the product you are going to get is COOH or COOH. Oxalic acid you will get. If it is a terminal alkyne, you are going to get oxalic acid, right? So if you take a non-terminal alkyne, for example, CH3, C triple bond C, CH3. This is an oxidation. The bond will get completely broken down here. You will get mixture of two acids. From this you will get one acid. From this you will be getting one acid. Sorry, you will get diketones. C double bond O, C double bond O, C, not acid, students. You will get a diketone. You will get a diketone. Remember, if it is a terminal alkyne, this is a terminal alkyne, you will get acids. If it is a non-terminal alkyne, you will get diketones. Only these two examples you remember, that is sufficient. Tell me students, if it was alkenes, what products you got? If it was alkene with cold dilute alkaline KMnO4, what products we get? Alkenes. Whether it may be terminal or non-terminal. Diols. Very good. If it was alkenes, we got diols as the products. So while studying, no, you study both alkenes and alkynes parallelly, because alkenes also undergo electrophilic addition only. Alkynes also undergo electrophilic addition only. Okay. So in both the cases, we have seen addition of hydrogen. In both the cases, we have seen addition of halogens. In both the cases, we have seen addition of hydrogen halides. In both the cases, we have seen addition of H2O. In both the cases, we have seen addition of HOX. So properties were same when we are studying for alkenes and alkynes. Just compare those two reactions and study how the addition was taking place in alkenes, how the addition is taking place in the case of alkynes. The same way oxidation also. When alkenes are treated with alkaline KMnO4, how the reaction is taking place? With cold dilute alkaline KMnO4. With alkanes, how the reaction is taking place? Then with hot and concentrated also the same thing. If it was alkenes, what products we will get? If it is alkynes, what products we are going to get? Same way ozonolysis. If it is alkenes, what products we will get? If it is alkynes, what products we are going to get? So while studying chemical properties, no, both alkenes and alkynes you can study parallelly. Okay. Complete writing. Right. Completed. Next one is with hot and concentrated KMnO4. Tell me students, if you remember, if it is alkenes on treatment with hot and concentrated KMnO4, what products you got? Hot concentrated KMnO4. Carboxylic acids we got, right? Terminal double bond was getting converted to carboxylic acid. What about if the double bond is in non-terminal position? Ketone you need to get. Ketone you used to get, right? Terminal alkene will be converted to carboxylic acid. Non-terminal was getting converted to ketone. Here, no students, irrespective of whether it is terminal or non-terminal, you will get carboxylic acids. You will be getting carboxylic acids. See here, for example, if I take ethine on reaction with hot and concentrated KMnO4. Next one, the second one is by using hot and concentrated KMnO4. Hot and concentrated KMnO4. Whether it may be terminal or non-terminal, always carboxylic acids will be formed. For example, this one oxidation. The bond gets completely broken down here. From this part, one carboxylic acid. From this part, one carboxylic acid. So one carbon atom containing carboxylic acid is formic acid. So we know that formic acid will further decompose to give carbon dioxide plus H2. Carbon dioxide plus H2. You take non-terminal. For example, if I take CH3, C triple bond CH. From here also the bond gets broken down. One will be formic acid, one will be acetic acid. Formic acid, I am writing it as CO2 plus H2. For example, if I take CH3, C triple bond C CH3, tell me students what products you will get? hot concentrated KMnO4. Yes, 2 moles of acetic acid you will get. So in this way, oxidation takes place with hot concentrated KMnO4. Whether it is terminal or non-terminal, you are going to get carboxylic acids only. If it was alkenes, if it is terminal, we got carboxylic acid. If it is non-terminal, we got ketones. But here, it is always carboxylic acid. Okay, na? Okay. Next, ozonolysis. Next oxidation reaction is ozonolysis. Next oxidation reaction is ozonolysis. Ozonolysis. Next oxidation reaction is ozonolysis. Tell me, students, if alkenes ozonolysis is done, what products you will get? Reductive ozonolysis, let us take. For alkenes, if reductive ozonolysis is done, what products will you get? Either aldehyde or ketone. No acids, no. If it is reductive ozonolysis, you will get only aldehyde or ketone. Just breaking the double bond, adding oxygen on both sides. If it was oxidative ozonolysis, then carboxylic acids and ketones. Carboxylic acids and ketones. Aldehydes will not be formed on oxidative ozonolysis because aldehydes will be further oxidized to carboxylic acids. Because aldehydes will be further oxidized to carboxylic acids. That was what we discussed in alkenes during ozonolysis. In the same way, alkynes, no students, on ozonolysis, we don't have two types of ozonolysis in alkynes. Only we have reductive ozonolysis. Only we have reductive ozonolysis, and reductive ozonolysis will always give either aldehydes or ketones as the products here. No carboxylic acids here. Right? For example, if I take ethine, first step is reaction of ozone in the presence of an inert solvent, followed by zinc in the presence of water, or it may be dimethyl sulfide, or it may be catalytic hydrogenation. Anything. That means it is reductive ozonolysis. It is reductive ozonolysis. Only this is there in alkynes. Nowhere oxidative ozonolysis is mentioned for alkynes. So what happens is, so you will get aldehydes or diketones. Bond will not be completely broken down. Always there will be a bond present between the two carbon atoms, right? And you will get this is one aldehyde, this is one aldehyde, which is called as glyoxol. Bond will not be completely broken down. For example, if I take propine, CH3C triple bond CH. So what happens? Here one double bond O, here one double bond O. That's it. CH3, C double bond O, C double bond O H. So in this way, no students, wherever there is carbon-carbon bond, there add double bond O to both the carbon atoms. That's it. Oxidative ozonolysis we discussed. Huh? I don't think so. Oxidative ozonolysis. Alkynes won't undergo much generally. Okay, even though I have not seen the reaction. If it was given, no. Okay, I must have seen somewhere, that's why I must have given. Maybe aldehydes may be undergoing, but not ketones, definitely. If it was given, no students, if you find anywhere, this is undergoing further oxidation, then it may undergo. Okay. But for reductive osmosis, this will be the product. Okay. If in options you don't have this, definitely it may be undergoing oxidative osmosis. Okay, na? It may undergo, but when there is a carbon-carbon bond, no, generally oxidation will be little bit difficult, but there may be some conditions where they undergo oxidation. But I'll check once. If I find the oxidative reactions, I'll tell. Okay. But nowhere it is mentioned oxidative osmolysis for alkynes. Only we have reductive osmolysis. If I have given, then I must have seen it somewhere. Complete writing. But compulsory, no students. If the question was like this, suppose if the question was like this, if the question was like this, then definitely this will be oxidative osmolysis only, because this is an oxidizing agent. So in such case, what will happen? So whatever the aldehyde we are getting, this will be further oxidized to carboxylic acid, right? If it is reductive osmolysis, the product reaction will stop here. But if it is H2O2, further oxidation is compulsorily possible. Okay. So there is a chance of getting this product also. We can't rule out that this product will never be formed. So because this is an oxidizing agent, there is a chance of aldehydes getting oxidized, because aldehydes can be oxidized by H2O2. H2O2, when compared to Tollens reagent or failing solution, this is a strong oxidizing agent only when compared to that. When Tollens reagent and failing solution are oxidizing aldehydes, then there is definitely a chance that even hydrogen peroxide can oxidize. So we can't rule out that compulsorily it won't take place. If there is hydrogen peroxide and if there are carboxylic acids, we can write the product. Okay, na? But if it is a ketone, that is not possible. Aldehyde what we are getting here, right? Next year, students. For example, if I take then what happens? Add one double bond go here, add one double bond go here. The product formed will be CH3C double bond go. So in this way you can write any given reactant reactive osmolysis. Will this undergo oxidative osmolysis, students? If it is given as H2O2, will this undergo further osmolysis? No. The reaction will stop here. Okay, because both are keto groups only. So this is how ozonolysis takes place in the case of alkynes. Ozonolysis takes place in the case of alkynes. Now students, we have discussed oxidation. These are the oxidation reactions of alkynes. But if you have some place where we discussed oxidation of alkenes, I forgot to mention one point there. Okay, I forgot to mention the point. If you have place there, you can write. Otherwise, here only you can write. In oxidation of alkenes. In oxidation of alkenes, no students, one point I forgot to mention. So that is, in oxidation of alkenes, if you have place, you can add it there. Oxidation of alkenes. Suppose you are having one alkene, students. I am using three oxidizing agents here. One oxidizing agent is Bayer's reagent. One oxidizing agent is Bayer's reagent, which is called a dilute alkaline KMnO4. cold dilute alkaline came. This is one oxidizing agent. Other oxidizing agent is OSO4. That is osmium tetroxide. This is also an oxidizing agent. Osmium tetroxide. This is also one oxidizing agent. One more oxidizing agent I am introducing is any peroxy acids. Any peroxy acids. See, peroxy means what? One oxygen must be additional, right? Carboxylic acid is RCOOH. That means RCO2H. One more oxygen if I add, it becomes peracid, right? RCO3H. Okay. So one best example for peroxy acid is MCPBA. Generally, you will be getting this in exam. MCPBA. What is MCPBA? Is metachloro perbenzoic acid. It is metachloro perbenzoic acid. Actually, benzoic acid is C6H5COOH. If I write as C6H5COOH, then it will be perbenzoic acid. Perbenzoic acid, right? So just remember the name. It is an peroxy acid. Wherever you get one oxygen additional in carboxylic acid, it becomes a peroxy acid. All these three are an oxidizing agents which will be converting alkenes to diols. But the difference is, no students, these two, the first two, one is Bayer's reagent, other one is osmium tetroxide, will give you cis diols. These are selective oxidizing agents. Here you will get cis diols. Cis diols means both must be either coming towards the observer or going away from the observer. Anything it can be. But both must be in cis position. So this is cis 1, 2 diol. In the same way, here also you will get cis 1, 2 diol. Either you will get this or you can write the other one also. Both will be enantiomers, right? This case, you will get, this is also cis 1, 2 diol. Both will be cis students. Either you will get towards or you will be getting away from the observer. Then next one is, you will get trans here. In this you will get trans 1, 2 diol. So these are called as stereoselective reagents. So just remember students, these are very important. I forgot to give this there. Okay, now, so all these are the three oxidizing agents which will be converting alkenes to diols. If I use Bayer's reagent, you will get cis diol. If you use osmium tetroxide also, you will get cis diol. If you use peroxy acids, you will be getting trans diols. Okay. So many reactions and reagents will be there. That's why I always tell, keep revising whenever you get free time. Okay. So more you do revision, more you can remember. Completed. Okay. Na? So oxidation of alkynes is done. Then there are last chemical properties of alkynes. Last chemical properties of alkynes are called as polymerization reactions. Polymerization reactions. polymerization reactions. So generally alkynes will be undergoing two types of polymerization. First one is called as linear polymerization. First one is called as linear polymerization. So the catalyst, important students, important. Many times it was asked in NEET and in CET exams. Okay, now. So in JEE, generally it is a memory-based question. Less memory-based questions will be having, but still it is important. So for linear polymerization, the reagent or the catalyst that is used is CuCl in the presence of NH4Cl. CuCl plus NH4Cl is used as a catalyst for linear polymerization. Very important. Remember this one. CuCl plus NH4Cl. Can anyone tell me, those who are preparing for Kvpy, what is the reagent used for the preparation of silicones? Catalyst. What is the catalyst used in the preparation of silicones? For Kvpy, you must have completed preparation by now. For preparation of silicones, what is the catalyst used? That is also a very important question which was asked many times. Don't know. Copper, students. Copper. Copper. Very good. Copper. So copper is used as a catalyst in the preparation of silicones. Right? So all these are very important points. So this is the catalyst used for linear polymerization. So what happens is, so if I take acetylene or acetylene, so this on treatment with CuCl plus NH4Cl, first you will get vinyl acetylene as the product. Vinyl acetylene. This is vinyl acetylene. Vinyl acetylene. Further, when it is made to react with one more mole of ethane, then you will get divinyl acetylene. This is called as a divinyl acetylene. Divinyl acetylene. See here, this is acetylene. C triple bond CH is acetylene. Vinyl means this group. Vinyl means this group. What is the mechanism of this polymerization? We'll discuss in polymers chapter. Anyway, next chapter we are going to discuss is polymers only in the Kvpy classes. So at that time I'll discuss how the mechanism takes place. But just remember the name vinyl acetylene. You know acetylene is CH triple bond CH. Vinyl means one hydrogen has to be replaced with vinyl group. You know vinyl is CH double bond CH2. This is vinyl group. So attach vinyl group to this triple bonds. Divinyl means what? This side already there is one vinyl group. This side also hydrogen you replace with another vinyl group. CH double bond CH2. It becomes divinyl acetylene. Okay, na? So products are not important, students, but this is important. Anyway, products you will come to know how to write the product when we study polymers chapter. No need to worry. But this catalyst, no, it is very important. For linear polymerization, we use CuCl plus NH4Cl as the catalyst. Okay, later. Then Then second type of polymerization reactions are cyclic polymerization reactions. Second type of reactions are cyclic polymerization reactions. Cyclic polymerization reactions. Cyclic polymerization reactions. So the catalyst used for these cyclic polymerization reactions, no students, it is red hot iron. Generally for cyclic polymerization reactions, we'll be using red hot iron. Okay, generally this is the catalyst used, right? So what is the cyclic polymerization? For example, if I take 3 moles of ethane, students, 3 moles of ethane, can anyone tell me the product? Yes, very good. We'll get benzene as the product. Benzene. We'll get benzene as the product. If I take 3 molecules of propine, if I get 3 molecules of propine, what product will you get? Can anyone tell me? One, 3, 5 trimethyl benzene. We get 1,3,5 trimethyl benzene. And there is a common name, students, for this compound. Anyone remember? Commercially, it is called as. Firstly, I must have given the name. No, it is called as mesitylene. It is called as mesitylene. Again, we will be discussing about this mesitylene in polymers chapter also, students. This is very, very important. Name of this is very, very important. Okay, because once they asked in the exam, in JEE exam they asked 3 molecules of propine on heating with a red hot iron, you will get a compound A. The number of sigma bonds and pi bonds in compound A is, the question asks this, number of sigma bonds and pi bonds in compound A. So first you need to know the name of the product. The name of the product is mesitylene. It is mesitylene. So remember, mesitylene is 1,3,5 trimethyl benzene. In the other exam, one more exam, directly they have given the name of the compound. Mesitylene contains how many sigma bonds and how many pi bonds. So 2 ways the question was asked from mesitylene only. So be careful with the calculation of hydrogens also. So at every place there will be one hydrogen. Okay, na? So that's why this compound is important, students, right? So try to remember the name of this compound. So these two are given in our NCERT textbook. Completed. If I take 4 moles of ethane, no students here, 4 moles of ethane, what product will you get? With 4 moles of ethane. Don't know. 4 moles of ethane, if I take 4 moles of ethane, I think that reaction is not there in your NCERT. But just for your information, I will be giving. 4 moles of ethane. So again here, no, either you can use red hot iron or you can use one more catalyst, methyl tetracyanide. anything you can use, nickel tetracyanide. You will be getting cyclooctatetraene. 1, 2, 3, 4, 5, 6, 7, 8. 4 means into 2, 8 carbon atoms. This will be the product form. This is called as cyclooctatetraene. Not there in NCERT, but one more polymerization reaction. So these, no students, these are the chemical reactions of alkynes. These are the chemical reactions of alkynes, and this is about alkynes chapter. Then we are left with one more, that is benzene. Okay. Complete writing this reaction. Right. So then coming to the last hydrocarbon is benzene. Already benzene, many reactions we have seen, all will be like revision only here. Benzene. Reactions are very easy also regarding benzene. So first coming to preparation of benzene. First coming to preparation of benzene. So in the preparation of benzene, see today only we have seen one or two methods of preparation of benzene, I remember. From benzene diazonium chloride we prepared benzene, no? From benzene diazonium chloride we prepared benzene. How did we prepare? By treating it with reducing agents we prepare. Okay. While studying phenols also we have studied, I think phenols we didn't study preparation of benzene. Okay, anyway. And phenol on reaction with zinc dust. Also we'll get benzene, right? So first important reaction, very important one is phenol on reaction with zinc dust. We'll get benzene. What product will you get, students? When phenol is made to react with K2Cr2O7 in the presence of H2SO4 or Na2Cr2O7 in the presence of H2SO4. Remember anyone? Phenol is made to react with K2Cr2O7 in the presence of H2SO4 or Na2Cr2O7 in the presence of H2SO4. What product will you get? Do anyone remember? Benzoquinone. Very good. The product form will be benzoquinone. You remember in this way. Benzoquinone. That is the product you will get when phenol is made to react with an oxidizing agent like Na2Cr2O7 or K2Cr2O7 in the presence of H2SO4. So that's why these are very standard reactions for 1 mark in your theory exam. So you need to keep revising. Okay, na? So this is one reaction. Then the second reaction is, if I take see students. So whenever you take sodium salt of carboxylic acid, you react it with NaOH and CaO. What is the name of this reagent? NaOH plus CaO. Soda lime. It is used for decarboxylation. Very good. It is used for decarboxylation. So what happens? CO2 from here will be removed. So when CO2 from there is removed, you get benzene only. So benzene plus Na2CO3 plus H2O. So even from this we can prepare benzene. Then one more method before only we have seen ethane on polymerization, cyclic polymerization we get benzene. So all these are the methods of preparation of benzene. Okay. So one reaction just now we have written, that is cyclic polymerization of ethane. Another reaction from benzene diazonium chloride we have seen today, that is on reaction with H3PO2 plus H2O or ethanol. There also we get benzene. So all these are the methods of preparation. Completed, students? Next, coming to properties of benzene. Properties of benzene. In properties of benzene, the most characteristic reactions of any aromatic compounds are electrophilic substitution reactions. So the first type of chemical properties are electrophilic substitution reactions. And you know what are these electrophilic substitution reactions? So one is halogenation, one is nitration, one is sulfonation, one is Friedel-Crafts alkylation, one is Friedel-Crafts acylation. You need to remember what are the electrophiles and you need to identify the order of reactivity of a given compound towards electrophilic substitution. So first I'll write the 5 reactions, then we'll see some questions based on that. What type of questions can be asked? For example, if I take benzene, students, benzene. So first one is on halogenation, that is chlorine plus anhydrous FeCl3. So you'll get chlorobenzene as the product. So the electrophile is Cl plus. Okay, na? So please go through the mechanism of electrophilic substitution, students, from first year theory notes, right? So there in the mechanism also questions will be asked. So in the mechanism you will be getting arenium ion, okay, which is also called as sigma complex. So try to remember the name. Try to observe what is the structure of that arenium ion. Okay, so that is important. You can go through that. Next one is nitration mixture. HNO3 plus H2SO4, both concentrated. Electrophile is NO2 plus, which is called as nitronium ion. Nitronium ion. Product formed will be nitrobenzene. Product form will be nitrobenzene. Next one is sulfonation. In sulfonation, the reagent is SO3 plus H2SO4 plus SO3, or directly H2S2O7, which is called as oleum. The electrophile is in neutral electrophile in this case, that is SO3. The product formed will be benzene sulfonic acid, SO3. In this case, next case, Friedel-Crafts alkylation reaction, CH3Cl or any RCl plus anhydrous AlCl3. Electrophile here is, so here you can see, students, you will be getting a carbocation intermediate. Check for rearrangement always. So whenever you are having a carbocation intermediate, always you need to check for rearrangement. So the product will be alkyl benzene. Then the last one is CH3COCl, RC double bond OCl with acid halides plus anhydrous AlCl3. So the electrophile will be RC double bond O plus, which is called as acylium ion. So the product will be aromatic ketones. C double bond O R. So these are the 5 electrophilic substitution reactions. So in all these reactions, this is very important because you are getting a carbocation intermediate. Check for possibility of rearrangement always. And regarding this sulfonation reaction, one important point is sulfonation reaction will always be under equilibrium. Sulfonation reaction will always be under equilibrium, students. I have given in the form of graph also. How we can tell that it is in the form of equilibrium? Because the graph for sulfonation will be in this way. So when these two peaks are equal, no, in kinetics also we have discussed. When these two peaks are equal, it indicates the reaction is under equilibrium. Generally, how the reaction must proceed? So the peak must be decreasing. With the proceedings of rate of reaction, the peak must go on decreasing because any chemical reaction will proceed towards equilibrium. Any reaction will proceed to get stability. Stability must be got means energy must be decreasing. Okay. So in this way graph you will get for sulfonation. Complete. Okay. Now the important questions that will be asked regarding this electrophilic substitution reactions is, for a given compound, identifying the reactivity order towards electrophilic substitution. For example, question is, arrange the following compounds. Arrange the following compounds in decreasing order of reactivity. In decreasing order of reactivity towards electrophilic substitution. Tell me, students, what will be the order of reactivity towards electrophilic substitution reaction of these four compounds? Tell me, what must be the nature of the groups on benzene ring? Electron donating or electron withdrawing? Very good. It must be electron donating groups. Electrophilic substitution means electron donating. Nucleophilic substitution means electron withdrawing. Tell me what will be the order. C, A, B, D. Yes. So the correct answer will be C, A, B, and D. Just identify the nature. So this is minus I. This is plus M. This is minus M as well as minus I. Okay, na? So what will be the answer? C, A, B, and D. So this is more electron donating than this. This must be wrong. Okay, na? So this type of questions you will get in the exam, students. Okay, na? Next is addition reactions. These are electrophilic substitution reactions. Next is addition reactions. Addition reactions. So what are these addition reactions? There are two addition reactions. First one is, to this benzene, if I add hydrogen in the presence of nickel, in the presence of nickel, Raney nickel, powdered form of nickel, then you will get 3 moles of hydrogen is required, so that it will be converting into cyclohexane. You will be getting cyclohexane, students. So this double bond gets broken down, hydrogens will be added. Okay. So you need to heat this because benzene is a stable compound, no? So without heating, the reaction doesn't take place. Then second one is the same reaction when it is done with 3 moles of chlorine, students. 3 moles of chlorine. Be careful with this reaction, right? Whenever there is benzene reaction with chlorine, no, you will get chlorobenzene also, just like electrophilic substitution reaction. But check whether there is a Lewis acid catalyst or not. Check whether there is a Lewis acid catalyst or not. So this must be in the absence of. This must be in the absence of any halogen carrier. Any halogen carrier means Lewis acid. Any halogen carrier means Lewis acid. If there is Lewis acid, electrophilic substitution will take place and you will get chlorobenzene. When there is no Lewis acid present, then you will be getting all carbons are substituted with the chlorines. Benzene hexachloride it is called. Okay, na? BHC. Benzene hexachloride. Benzene hexachloride. BHC. So this reaction is important, students. Be careful. If there is Lewis acid catalyst, we get chlorobenzene. If there is absence of Lewis acid, you will be getting this. These are the 2 addition reactions of benzene. Okay. Then there is one more last reaction for benzene, that is oxidation reaction of benzene. Oxidation reaction of benzene. Oxidation reactions of benzene. Oxidation reactions, right? So first oxidation reaction is combustion, students. So we know that benzene is an hydrocarbon. So which on oxidation we get CO2 plus H2O. So 6 CO2 plus 3 H2O, 15 by 2. So this will be the oxidation reaction of benzene, that is combustion, which will give carbon dioxide and water. There is another reaction which is very important, mainly for CET and NEET exams it is important. That is reaction of benzene with 9 by 2 moles of oxygen, students, in the presence of vanadium pentoxide. Remember this catalyst. In the presence of vanadium pentoxide as catalyst, carbon dioxide gas will be removed from here along with water molecules, and you will be getting an acid which is called as malic acid. You will be getting an acid which is called as malic acid. It is called as malic acid. Malic acid. So this further will undergo decomposition on heating, and you will be getting malic anhydride. This is called as C double bond O. O C double bond. Water molecule will be removed, and you will be getting malic anhydride. MALEIC. LEIC. Malic anhydride. Malic anhydride. So this reaction is important, students. Malic anhydride. Complete. Important reaction, students. Please concentrate on this reaction. Okay, na? So actually, these are the chemical reactions of benzene, students. So with this hydrocarbon part is done. I'll give two oxidation reactions. Just try to tell me the products. Let me see how much you remember. Those two are also aromatic compounds only, but they are hydrocarbons. Right? What is the product in this case? This is toluene made to react with KMnO4 in alkaline medium followed by hydrolysis. Anyone remember? What happens when you treat any compound which is containing an alkyl group on benzene ring with this compound? What is the function of this, students? Oxidizing agent, right? Alkaline KMnO4 is an oxidizing agent. It will oxidize this side chain to what? It will oxidize this side chain to what? Carboxylic acid, no. Irrespective of the length of the side chain on benzene ring, irrespective of the length of the side chain on benzene ring, on making it to react with the alkaline KMnO4, it will be oxidized to COH. You are not reading, students. I am telling you, if you don't read organic chemistry daily, then it will become really very, very difficult for you at the time of exams. Okay, I am telling you, you will be absent only for the exam, definitely. Because by seeing many reactions, so it will be very difficult for you. So that's why read the reactions carefully. So you know that it is an oxidizing agent. I said that. So no, whenever there are specific points, you must remember that specific points. 2 or 3 times or 4 times if you read, you won't forget that. Okay, na? So just if you listen, if you go home, no, even though you may understand in the class, but definitely you'll forget. So whatever may be the length of the carbon chain on benzene ring, when you treat it with KMnO4, it will be completely oxidized to COH. What about this one, students? Yes, you'll get benzaldehyde. You'll get benzaldehyde as the product. What is the name of this reaction? What is the name of this reaction? Very good. It is called as Ithard reaction. It is called as Ithard reaction. So this point you need to be careful. Okay, na? So just for your revision sake, I have given the two reactions. This is also an aromatic compound. Okay. So this is about hydrocarbon, students. Okay. So I hope there will be no wastage by doing this revision, because if I do revision and if you are not reading, again it is a waste of time. So every Monday and Thursday, 2 hours will be just a waste of time if you don't read. Okay. So listening to the class is different and reading is different. If you just listen to the class, you will understand. But without reading, you won't remember. Okay. So please make utilize of this revision classes properly. Okay, na? So Thursday we won't be having Kvpy class, revision class. We'll be having it on next Monday only. But next I am not going to do first PU concept. I'll see whether to start polymers or do biomolecule. We'll discuss later. Okay, na? But in next regular class, we'll be doing MCQs of amines. So if while doing MCQs of amines, to be confident of that MCQs, please read the concept of amines and come. Okay, now. So if you read the concept of amines, all the reactions and everything, so it will be easy for you to solve MCQs while we are discussing in the class. Okay, students. Thank you. How many organic reactions to read a day means daily whatever is discussed, that if you read, no ma, Sanjana, it will be sufficient, right? Daily whatever we discuss that you read, it will be sufficient. Every week, no, one day you keep for revision of all the reactions what you have studied in that week. One day you keep it for revision. Okay, na? But we have completed organic, right? Now there is no point in asking that question. Okay, but anyway, if you start revising from today, so please start reading from haloalkanes and haloarenes, but first you read amines because we are going to do MCQs. So anyway, MCQs will be done in Friday's class only, I think, because tomorrow there is no classes. So these 3 or 4 days you can utilize for revising amines. Okay. Saturday, na? So Saturday we are having another class. Till that time you can revise amines properly. You can revise because small chapter only. Even the many reactions, it is a small chapter. Thank you. Ankita, all are important only. Ma, in class, when I am telling, I am writing, no, beside wherever I write important, that will be important. In class only, while giving reactions, I tell no important, those are only important. Okay.